This is example video 18, and we're looking this time at dilutions. Now, dilution is when you're changing the amount of water, specifically adding water to a solution, or adding solvent to a solution. So in dilutions, it's only the amount of water that changes. The mass and number of moles of solute remains the same, both before and after dilution. That's a very important idea. So for example, I've got a solution here, solution number 1, and I'm adding water to it, so therefore the volume of solvent's increasing to make solution number 2. But if you think about it, you can see that, well, I've only got a certain number of moles of solute in solution 1. The only thing I'm changing is just adding water. That's not changing the number of moles of solute. I've got the same moles of solute in solution 1 and solution 2. So even though the volume of solution 1 is less than the volume of solution 2 because it's got much less volume, the concentration of solution 1 is higher than the concentration of solution 2 because I've got more solute per litre, but the moles of solute in solution 1 equals the moles of solute in solution 2. And that's very important, the idea that the moles of solute has not changed. So we can make the conclusion the moles of solute in solution 1 equals the moles of solute in solution 2. But because we know number of moles is equal to the concentration times volume, that means we can rewrite that as the concentration of solution 1 times the volume of solution 1 must be the same as the concentration of solution 2 times the volume of solution 2 because the moles are the same in each. Basically what's happening is if we're increasing the volume, we're decreasing the concentration by just the same amount, so this product remains the same. And what that means, where C1 and V1 are the concentration and volume in moles per litre and litres of the original solution, and C2 and V2 are the concentration in moles per litre and volume in litres of the final diluted solution. But very important, this equation is sometimes tempting to use all the time because it looks like it can solve all your problems, but it only ever works in dilution questions, and if you try and apply it anywhere else, you will get the wrong answer. So the only time you're allowed to use this question if the question says water is added, or if the question says it is being diluted. Otherwise, do not touch this equation, it will lead to despair. Let's move on to some examples. So example 18. In all of these, we're doing dilutions. In the first one, we're calculating the concentration of sugar. If 2 litres of a 0.2 mole per litre solution is diluted to 5 litres, that word diluted gives us the green light to use C1V1 equals C2V2. Next question, volume of final solution if 4 litres of a 0.8 mole per litre solution is diluted to 0.2 moles per litre. Once again, that word diluted means we can use that formula. And finally, what volume of water must be added to dilute 5 litres of a 0.1 mole per litre solution to 0.02 moles per litre? Adding water and dilution, yes, we can use C1V1 equals C2V2 for these questions. Let's see how it applies. So for all these dilution questions, they're fairly straightforward. You just need your data. And the data you need is the equation, C1V1 equals C2V2, and the only things you need to know are C1, V1, C2, and V2. So have a go at this question. See if you can figure out what C1, V1, C2, and V2 are in this particular question. So pause the video and have a go at that. Okay, hopefully you found that we started off with a 0.2 mole per litre solution, so C1's 0.2 moles per litre. The volume was originally 2 litres, so the volume 1 is 2 litres. We don't know the final concentration, that's what we're trying to find, and we've been told it's diluted to 5 litres, so we've got all that information apart from C2. Now, we can rearrange this equation by dividing both sides by V2 to make it C2 equals C1V1 divided by V2. Now we can substitute, that's just 0.2 times 2 divided by 5. It tells us the final concentration of the solution is 0.08 moles per litre, and that's to one significant figure, just like the data in the question. Looking at B, this time, once again, same formula, C1V1 equals C2V2 because it is a dilution. Have a go now, pause the video and see if you can figure out C1, V1, C2 and V2. Okay, hopefully you got that the concentration number 1 was 0.8 moles per litre and you had 4 litres to start with. It said it was diluted to 0.2 moles per litre, therefore your concentration 2 is 0.2, and we want to find what's the volume of the final solution. So we can rearrange this equation with V2 the subject by dividing both sides by C2, such as C1V1 divided by C2. Now we can substitute, which is just 0.8 times 4 divided by 0.2, and then if we go ahead, that gives us 16 litres. But looking at these data, 1 significant figure, 1 significant figure, we've got to go to 1 significant figure, which means it's about 20 litres to 1 significant figure. Now, the last question, this is the one that's going to try and trick you up in your prelim exams and your HSC exams because it looks like a simple dilution, but there's one small twist to the question. So see if you can figure out what the small twist to the question is by reading it again. Hopefully you figured out that you haven't been asked for the final volume or final concentration or initial concentration. They're asking you for what volume of water must be added, and that's that extra little twist. Now, if we start off with a solution with volume 1 and end up with volume 2, the volume of water we added, or V added, must just be the difference. So it's V2 minus V1, and that's what the question's asking you to find. You've got to find V2 and V1, and the difference between them is how much water you've actually added. So let's see if we can calculate that. How are we going to find V1 and V2? Well, it's just a dilution question. We can go back to C1V1 equals C2V2. So see if you can put your data in here. And hopefully you figured out you started off with 5 litres of solution which had a 0.1 mole per litre concentration. You diluted it to 0.02 moles per litre. We've got to find V2 in order to find the volume added. So there's our equation, rearranging it to make V2 the subject, i.e. dividing both sides by C2. We can now substitute our answers in, or numbers in. So the original concentration was 5, so the original volume was 5, original concentration was 0.1, the final concentration is 0.02. That tells me the final volume is 25 litres. It's very tempting to stop there because that feels like the end of the question, but we know it's not. We've got to find the volume added. So now we can say the volume added is just V2 minus V1, which is the 25 litres, take away the 5 litres we started with, which gives us 20 litres to one significant figure. And that's how you do dilution questions.